Okay, inverse functions. Swap the x domain with the y range. Remember, your domain is your input. X's are almost always your input. Your y is the range, and then solve the new equation for y. That is how you find an inverse function. We will be finding inverse functions. I'm going to tell you some inverse functions are impossible to find, but none of the ones that I make you do. Okay. Inverse notation. If f of x is the original function, f to the negative 1 power is its inverse. Now, normally, something to the negative 1 power means 1 over that, not when it's like this. F to the negative 1 is the inverse of f. It is not 1 over f. The inverse of a function is not 1 over that function. It may be the inverse of a number, but not the inverse of a function. Okay? A reflection line. Inverses, and this will be important later, are reflected through the line y equals x. And this will be very important later. Okay, inverse functions are reflected through the line y equals x. And then the last part that you can't read because it's covered up. Function test, the vertical line test. If a vertical line can be drawn such that it passes through 2 or more points, the relation is not a function. We've actually done that before. So remember the vertical line test. If it passes through more than once, it's not a function. It's a relation. Okay, I don't know if we actually do that in here, but we did that before when we were testing out functions. Is it a function, yes or no? Vertical line test. That's what that last part is. Questions on this information that I just shared with you? Okay. So, problem 1, determine the inverse of the set of points and graph the inverse. So here's what I want you to do first. Graph those 3 coordinate points. Graph the original points. Okay, there are the original points. Now, to find the inverse of the points, pay very close attention. This is extremely difficult. The inverse of the point 4, 3 is the point 3, 4. Did you catch that? Let me do you on the next one to make sure you understand. The inverse of the point negative 2, 1 is 1, negative 2. One more time, just to make sure you understand that this is really hard, really, really hard. The inverse of the point 0, negative 5 is negative 5, 0. Can you handle that? Plot the points. I want to show you something really nifty when you do that. So I've got the points and I've got their inverses plotted. Connect the point with its inverse. Connect the point with its inverse. Okay. Now here's something that's really cool. When you go back to here, we said down here the reflection line is the line y equals x. If you draw in that reflection line, you can see that every point is reflected across. Here's my original. There's the one reflected across. Same distance, perpendicular through it. The lines are perpendicular here. Then they're the same distance on each side. It's reflected through that reference line, reflected through the line of reflection of y equals x. Inverse functions, no matter what the function is, always reflect across that line. Any function that is an inverse of another one, the two of them, if you graph them, they will reflect across that line. That will be very important for something we're going to do here shortly. Now, I don't expect you to do this on every single one of them, but I did want to show you on this one what we're dealing with here with reflections. Okay, find those, plot those points, plot their inverses. Okay, the inverse of 0, 2 is 2, 0. Wow, you guys, I'm so impressed that one person bothered to tell me what the answer was. The inverse of negative 5, 0 would be?
0, -5.
Oh, that's a little better, but man, it sounds like I don't have anybody in here. Okay. And you plot the points. 2, 0, 0, -5. And the original point here and here, and I don't really care about connecting them up or anything like that yet. Okay, for this next part, you need to get a pencil.
Yay.
You need a pencil. I have a few here. If you don't have a pencil, you will need a pencil for this next part. Pens don't work very well. Okay? So what we're going to do is we're going to draw the inverse using the paper fold method across the line y equals x. Here's what you do. Pay attention. I obviously cannot fold this, so I have paper to share how to do it with. Unfortunately, I wish I had larger pieces of paper, but you will get the idea. First step, draw the line y equals x. If you have a ruler, that would be a good thing to do, would be to draw the line y equals x. That's what you do. Now, the directions will not be no longer be on the board, but they will be available to be heard, because I can't do this next part on the board. Make sure I get this good here. Draw the line. Y equals x. Okay. Here's what you need to do next. On the graph, we're trying to find the inverse. Our original graph is this parabola here. We want to graph its inverse, and this will work with any graph. You take your pencil, and you rub with your pencil along that graph. That's what you need to do. Literally, you take your pencil and you rub it, and the more you do, the better this is going to work. And the more you stay inside the line and on the line, the better it will also work. Okay, now is when it gets a little tricky. I'll give you a minute to finish. I've seen this work with pen occasionally. This will not work with a felt pen and marker at all. Pencil's the best. And what you do is you take your paper, and it's kind of hard for you guys, but you can do this. You fold it so it's folded. So it's folded on. Fold it across the line, y equals x. Ooh, I did a lousy job. So I want to refold mine. But it's folded along the line y equals x. You want to fold it on the line y equals x. That's what it's folded. So you fold it over. So it's folded on this line. I unfolded it so you can see what I'm talking about. That's the line you fold it on. You fold it on the line y equals x. You get a good, nice, tight fold. Now, here's what you're going to do. While it's folded up, you're going to burnish it. Anybody in your art class? Anybody ever do any burnishing? There's actually a tool for burnishing. My favorite tool for burnishing is my thumbnail, because it works really good with my thumbnail, but I don't have plastic fake nails. I got real short nails. Rub on there. That's what burnishing is. Really good, making sure you get where the original graph was. Rub it really, 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 really good. Rub it really, 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 really good. Rub it really, 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 really good. Just keep rubbing it, rub it, rub, 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 rub it. And then when you unfold it, you have transferred your pencil over and you have created your inverse graph. That is called the paper fold method. Okay, when you do that, you have created your inverse graph. Now I will take. Yeah, you got to rub really hard to get out a lot of lead on there. If you don't, it don't work. Okay, now I went back over what my transfer was to give you. This is what your inverse looks like. Okay, I will post online. I did these for all 4 of the graphs we're supposed to do this with. They will be posted online, a separate PDF that has the graph and the inverse on it. It's not real pretty looking, but it does work. Okay? So to make sure you know how to do this, do the next one on this page. I'm not going to do the other 2 because I don't want to do a lot of these together. Do the next one. Draw the line, pencil over it, fold it, rub it. And yes, this will be a test question. This is probably the test question that everybody gets. And I do mean everybody always gets this test question. No, you do not need to know the word burnishing. I do that to show off.
Yes. High stuff. No, he's on my skin.
Okay.
Potato, cheater.
Let's see. One, 2.
It didn't work.
If it didn't transfer over, you need to do more pencil or you need to rub harder, one or the other.
Man,
No, I'm serious. Usually the problem is not rubbing hard enough. Usually the problem is not putting enough pencil lead down to transfer over. It's usually what happens. Five. So 1, 2, 3, 4. 2. 1, 2, 3, 4. 2. 1, 2, 3, 4. -2. Yeah, that looks about right. Okay, so on the second one, now on the second one, you can actually kind of cheat a little bit. If it's all straight lines like this, find the endpoints, plot the inverse points, the endpoints, and connect dots, which is what I just did. But that only works if it's straight lines. It only works if it's straight lines. Okay. Now, this one and this one, I'll have the answers online. Let's go to these. Okay. Quiet, please. This is where it gets difficult, or algebraically difficult, I should say. So far, like I said, it's been fun, it's been easy. This is where the rubber hits the road. Find each inverse algebraically. So my original function, f of x is 3x plus 5. I want to find the inverse function. Guys, your first step I've actually already done for you. First step, take f of x, replace it with y. Step number 2, solve for x. Subtract 5. Y minus 5 equals 3x. Divide by 3. Y minus 5 over 3 equals x. If I take this y, let me do this, move this up. Take this y, replace it with x, swap the x and y. That's my inverse. My inverse is x minus 5 divided by 3. This function and this function are inverses. The input of one is the output of the other. Every x coordinate for one is the y coordinate for the other, the corresponding y coordinate for the other, and vice versa. Any xy that works here is the exact opposite here. I put 3 in here, or I put 1 in here. 1 times 3 plus 5 is 8. Put 8 in here, I get 1. That's what inverse functions do. I put an x in here, get a y value. I take that y value, put it in here. I get my original x that I started with. That's what inverse functions do. We've worked with inverse functions already in here when we were using squares to solve square root problems. When we were using square roots to solve square problems. Those are inverse functions. One undoes the other. Inverse functions are extremely important. They're ways of solving equations. We're going to be using them extensively in the next chapter we do. Extensively. Okay. So let's do this next one here together. Same thing. Your first step is to take f of x, put it into y. Like I said, I already did that for you. Your next step is to solve for x. I want to get x by itself. Add 2 to both sides. Y plus 2 equals 1/4 x. Next step, get rid of the 1/4. To get rid of the 1/4, what do? Multiply by 4. So I multiply both sides by 4. Remember, it's that whole thing times 4. So I get 4y plus 2 equals x. That means my inverse is 4x plus 2. Not difficult, but it's easy to get confused. Let's do it again. It's a little harder on this one. A little harder on this one. Same process, first step, like I said, is already done. Swapped out f of x for y. Solve for x. So to do this, I need to get x squared by itself. So that means I add 1 to both sides. So we get y plus 1 equals 2x squared. What am I going to do next? Nope. Divide by 2. I want to get the x squared by itself before I do that. Divide by 2. Y plus 1 equals 2, or over 2, sorry, equals x squared. Now I want to get x by itself. How do I undo x squared? I take the square root. My square root is, in square rooting undoes square root. That's the inverse of squared, square root. Square root both sides. So I get the square root of y plus 1 equals 2 over 2 equals x. So my inverse function is the square root of x plus 1 over 2. Now, with squares and square roots, you have to be careful. It's tricky because their inverses don't always work correctly, and squares is one of the ones where they don't work correctly. Let's say I put in -1. My original one is -1. -1 squared is 1 times 2. Minus 1 is 1, right? So if x is -1, then when I come down here, if I put in 1, I should get -1 back out, right? 1 plus 1 is 2. 2 divided by 2 is 1. Square root of 1 is 1, not -1. Here's what we do, but you don't have to do this, but I wanted to point it out. That's not a true inverse, but what you can do is you can say, listen, I'm not going to use the entire everything. I'm not going to use all possible x's. If you limit what we talk about, so what I do is say, hey, in my original problem, all my x's need to be greater than or equal to 0. If I don't use negative x's, I can get an inverse function with squares. If I use negative x's, it doesn't work. You won't have to do that, but I wanted to point out that you have to be kind of careful about that. Okay? This is one of those ones where it doesn't always work. You have to limit what you talk about. You won't be asked to do that. You'll just be asked to do this part, and I'm okay with that. But be aware that there are limitations. Inverses can get kind of goofy. Okay? Let's do the next one. So, my first step would be to add 1 to both sides. Y plus 1 equals x cubed. And then how do I undo a cube? Cube root. Take the cube root of both sides. So the cube root of y plus 1 equals x. So my inverse function is the cube root of x plus 1. And you don't have to worry about things not working with odd powers and odd roots. It's only even powers that get really goofy. Odd powers, not a problem. Even powers, generally it's that way. There are circumstances, but that will be something that if you keep going, you'll have to deal with later, but not in here. Okay? You're with me so far. It's not too bad, is it? It's not that hard. It is probably one of the things you have to be most careful about. Okay? So your turn, do these two. And then I think the next page, same thing. So do these two problems. Okay, looks like everybody's done with these first two, so let's do them. Once again, change f of x to y, solve for x. Subtract 3. Y minus 3 equals negative 6x. Divide by negative 6. Y minus 3 over negative 6 equals x. So our answer, our inverse function is x minus 3 divided by negative 6. Easy peasy. Next one, same thing. Subtract 1. Y minus 1 equals 2/3 x. This one's a little more difficult than the other one with the fraction front, but I still just multiply by 3/2. Times 3/2. Whole thing times 3/2. Now this side becomes x. This gets a little trickier. Here's what you want to do to make it look pretty. Distribute the 3. 3y minus 1. And technically, we're going to distribute the divided by 2 as well. Oh, sorry, 3y divided by 3. Divided by 3, my bad. Divided by 3. But distribute the 3 across, and then just put the 2 underneath. It looks prettier this way. Okay, it looks a little neater. If you gave me 3/2 times y times x minus 1, I'd be okay with that. This looks nicer. It's what we want is things to look nice. So my inverse is 3x minus 3 divided by 2. Okay. Questions? Okay, do those two if you have not already. Okay, it's been pointed out that back on this page, I made a mistake. But my students let me get way ahead of myself before correcting, so it's their fault. I got to go back and record all this stupid crap all over again. 4 times 2 is not 2, it's 8. So that should be an 8 there. Now, better. Yeah, I did screw up. But you should have said something to me earlier. And yes, my rant is on tape. Anybody who watches this that doesn't know this class must be thinking I'm some cranky old man. Okay. So once again, already started the first step. Add 2 to both sides. Y plus 2 equals 5x squared. Divide both sides by 5. Y plus 2 over 5 equals x squared. Square root both sides. And the square root of y plus 2 over 5 equals x. So my inverse function, square root of x plus 2 over 5. And last but not least, this is actually pretty easy. First step, divide both sides by 7. Y over 7 equals x cubed. Cube root of y over 7 equals x. So my inverse function is the cube root of x over 7. Easy. This is one of those things that does get touched on in more detail later on in your academic career if you keep going. Inverse functions are important. We've used inverse functions in here. Inverse functions are how you solve some equations. The only way to solve some of the stuff that we're going to be doing in Chapter 6, gentlemen, is to use inverse functions. It's the only way to do it. The only way to solve square roots are to square them. Inverse functions. They're extremely important concepts and ideas. I'm not asking you to find really difficult ones. That's for other classes. And some of them algebraically cannot be found. You cannot separate the variables and do that. Some of them can't be done that way. And that's okay. We don't worry about those.